This video is on Unit 3, Chapter 7, Rational Exponents and Radical Equations, Lesson number 2, focusing on rational exponents. So when we talk about rational exponents are exponents that are fractions. So expressions with rational exponents can be rewritten as radicals using the following rules. And I'm going to talk about those rules in just a second. But what I want to do is I want to put that into terms that I think you'll understand. So when we have exponents that are fractions, those are radicals, but they're just in a different form. So what we're going to learn in this lesson is how to convert from rational exponents to radicals and vice versa. We're going to go from radicals back to rational exponents. So in this first one, a to the 1 over n, a is called the base, and 1 over n is your exponent. And notice in this one that the numerator is a 1. That's kind of important. And it's read the nth root of a. We can rewrite the nth root of a in radical form, where n is the index and a is your base, and that goes underneath the radical. So basically what you need to remember is that the denominator is the index. The denominator is the index on the radical, okay? So look at this next one, a to the m over n. A, again, is my base, and it's going to belong under the radical. The denominator is going to be the index, and then there's an m here. The nth root of a raised to the mth power can be rewritten in two different ways. Again, the denominator is still the index of the radical. The base still goes under the radical, but the numerator becomes the exponent either on the a or on the whole radical itself. So let's look at some examples here. Converting between exponential and radical form, directions say write each expression in radical form, simplify if needed. So number 1 says x to the 1/4 power. Well, x is the base. The base goes under the radical. The denominator is the index. Now that numerator is a 1, so we're done. On number 2, I have 15n raised to the 1/2 power. Now notice that the 15n is inside parentheses. They're both being raised to the 1/2 power. So the 15n is your base. The numerator is a 1. So again, we're done. Here we are done. Now, some of you are going to want to put a 2, but if you will recall, a square root with no index is an understood 2. So for number 2, it should look like the square root of 15n. On number 3, again, the numerator is a 1. So we're going to put that 24 underneath that radical. The denominator is a 3, and there's my index. Now, this one we can actually simplify. The first two we could not. The square root of 15 is not going to simplify, n is not going to simplify, and the 4th root of x is not going to simplify. But the cube root of 24 can. So what we're going to do is we're going to go to our y equal, put our 24 divided by, what was the index again? The index is a 3. So just like we learned in lesson number 1, we're going to divide by x cubed, go to our table of ordered pairs, and look for how to reduce this. And this is going to reduce to 2 times the cube root of 3. So 2 times the cube root of 3 is our answer on number 3. All right, so let's look at number 4. Too far. Number 4, I have 7 to the 2/3 power. So the 7 is the base. It goes underneath the radical. The denominator is a 3. And then we've got this squared. So I'm going to put the square on the 7. And 7 squared is 49. Now we can try to simplify this. The cube root of 49, y equals 49 divided by x cubed. And what you're going to find here is that it does not simplify at all. The 49 is the only perfect whole number there. So it's not going to simplify. It's going to stay the cube root of 49. Number 5, the k is your base. The denominator is a 2, so that the index is an understood 2. And then we've got k to the 7th power. Now with exponents, remember from lesson 1, in order to simplify this, we're going to take that 7 and divide by 2. 2 goes into 7 3 times with a remainder of 1. So we've got k to the 3rd power on the outside and k to the 1st power on the inside. And again, we don't need a 2 there because it's an understood 2. On number 6, same thing. We're going to put the 3 underneath. The 4 is the index, and I'm going to put the 5 on the 3. I'm going to go to the calculator and do 3 to the 5th power so I can figure out what that number is. 3 to the 5th power is 243. So this is going to become the 4th root of 243. And then what we want to do from there is go to y equal. And we're going to do 243 divided by x to the 4th power. Because again, the index was 4. Second graph, looking at my table, it's a 3 and a 3. So this is going to be 3 times the 4th root of 3. 3 times the 4th root of 3. Number 7, AB to the 3/4 power. Again, the A and the B are both inside parentheses. And the 4 is your index, and the 3 is on the A and the B. So what that's going to do here is that exponent, if you think back to that first lesson, that exponent is going to distribute to both the A and the B. So this is going to become the 4th root of a to the 3rd, b to the 3rd. Now, because we only have 3 a's and only 3 b's, there's not enough for anything to come out of that radical. Number 8, we're going to have the cube root of negative 6x squared. Now, think about how to square that. Negative 6 squared is a positive 36, and then we've got x squared. Now, for the variable, there's not enough x's in order to bring anything out of that radical, but let's see if we can simplify this 36. Say 36 divided by x cubed, 36 divided by x cubed, and we get nothing. We get nothing. It doesn't simplify. So that's our answer for number 8. Number 9 is a little different. Let's look at number 9. There's a 7 in front. So basically that 7 is like a whole number in front of the radical, and it's a square root, understood 2 here. And we have our 12w underneath. Now there's not enough w's to do anything with, but can we take the square root of 12? Can we simplify that? So 12 divided by x squared. Is anything going to come out? Yes. So we have 2 and a 3. So 2 times the square root of 3. But what are we going to do with that 7? So it's going to be a 7 times the 2 square root of 3w, which is going to be 14 times the square root of 3w. All right, so the next section is going back. It says write each expression in exponential form. So we're going reverse. So notice in number 10 that the index is a 3, and there's no other exponents here. So we're going to take the 16, which is the base, and its exponent is going to be 1/3. And it's a 1 because, again, there are no other exponents there. On number 11, x and y are both inside that radical, so we're going to keep the x and the y together inside parentheses, and that's going to be a 1/2 because that's a square root. On number 12, 8w to the 1/4. Now let's look at number 13. Number 13 says 11 squared underneath that radical. So the cube root of 11 squared, this one's a little different. 11 is still your base because 11 is the base number under the radical. The 3 is the index, so I know the 3 is going to be the denominator. The 2 is going to be the numerator. Same thing on number 14. K is the base. 4 is the index, so it's the denominator, and 5 goes into the numerator. So reversing back to exponent form is pretty simple. Now, number 15 is written a little different. Um, Again, the index is an understood 2. Your 3 and your m are your base, and the denominator is a 2. But what's the numerator on this one? Well, the 7 is on the outside of the radical, but I showed you earlier that that's just the same thing. If you look back up here, the exponent, the numerator, can either be inside or outside. All right, let's move on to this next section. The next section is all about simplifying expressions with rational exponents. And we've got some rules that we may want to go back and look at. Exponents don't follow rules. I call exponents the teenagers of math. So with exponents, if it says to multiply, exponents are going to add. If it says to divide, exponents are going to subtract. If you've got an exponent raised to an exponent, you're going to multiply those exponents. I can't think of anything else off the top of my head, so I may have some more as we go throughout this process. I may add to that, but let's look at number 19. So the steps here say to rewrite all radicals in exponential form. Use the exponent rules to simplify the expression and then write your answer as a radical in simplest form, rationalize if needed. So for number 19, I have x to the 1/3 times x to the 4/3. So here the operation says to multiply. And again, my exponents are a 1/3 and a 4/3. So when the operation says to multiply, exponents are actually going to add. So we're going to add 1/3 plus 4/3. Alpha y equal is a fraction, 1/3 plus another fraction, 4/3, gives me 5/3. So this becomes x to the 5/3 power, and we're going to change this back to a radical. It's going to be the cube root of x to the 5th power. Now there's more x's on the inside. They're bigger than the index. So 5 divided by 3 is going to be 1 with a remainder of 2. So this is going to become an x times the cube root of x squared. Number 20 is the same as number 19. Let's jump down to number 21. So the operation on number 21 says to divide, which means if the operation says to divide, exponents are going to subtract. So m to the 5/2 divided by m to the 7/4 means that we need to subtract those exponents. One thing I have not said is your bases must be the same. So only because they both have a base of m am I allowed to go ahead and subtract 5/2 minus 7/4. So alpha y equal 5/2 minus alpha y equal 7/4, and we get 3/4. So this is going to become m to the 3/4 power. We're going to change that back to a radical, and it's going to be the 4th root of m to the 3rd power. Now there's not enough m's here. The number of m's that you have inside is smaller than the index, so we're good. Looking at number 22, I have a to the 1/3 and that's being raised to the 5 halves. So this is an exponent. My 1/3 is an exponent, and it's being raised to another exponent. So my exponents are going to multiply together. The base is an a, so we're going to keep our base, but we're going to multiply 1/3 times 5 halves. So I'm going to go back to my calculator. Alpha y equal 1/3 times 1/2? 1/3 times 5 halves, sorry, times 5 halves. And I get 5/6. So this becomes a to the 5/6 power. Rewriting that in radical form, we have the 6th root of a to the 5th. And again, the number of a's on the inside is less than the index, so that's my answer. Number 23, let's look at number 23. The reason why I want to look at number 23 is because on number 23, my base is just a number, and sometimes it can be a little confusing for students. Your base is the 32, but the exponent is a 1/2, and that's being raised to the 1/2 power. So going back to these rules, exponent raised to an exponent, we're going to multiply the exponents, but the base stays the base. So 32 is going to be raised to the 1/2 times 1/2. So 1/2 times 1/2 gives us 1/4. And we're going to change that back to a radical. 4th root of 32. We need to see if we can simplify that. Y equals 32 divided by x to the 4th power, second graph. And it does reduce to 2 times the 4th root of 2. 2 times the 4th root of 2. Let's look at number 25. 25, 26, 27, and 28 all have negative exponents. So we need to talk about negative exponents. Negative exponents are fractions. Now let me show you what that means. So negative exponents are not allowed. We are not allowed ever to keep a negative exponent. We have to change it to a positive exponent. To change it to a positive exponent, we're going to create a fraction, and we're going to move that negative exponent and its base to the other part of the fraction. So my 100 to the negative 1/2 power is now going to be 100 to the positive 1/2 power, but it's going to be in the denominator. And it looks like the fraction just flipped because when we leave nothing in the numerator, we have to hold its spot with a 1. So now we're going to rewrite this as 1 over, this becomes the square root of 100. 100 is a perfect square. The square root of 100 is 10. And my answer here is 1/10. Let's look at number 28. 28 is a little different even. Actually, let's back up to 27. Number 27 is negative 216 to the negative 1/3 power. I'm going to make that a fraction. I'm going to move that negative 216 to the denominator, and the negative 1/3 becomes a positive, and I left a 1 in the numerator. Rewriting this is the cube root of negative 216. Now, the reason why I wanted to show you this is because only the exponent changes signs from a negative 1/3 to a positive 1/3. Notice the negative 216 did not change. So now we're going to do the cube root of negative 216. Again, remember from that first lesson that that means I'm going to have a negative in the on the outside, and the cube root of 216, I want to say, divided by x to the 3rd power. And it's a perfect cube, which is what I was trying to say a second ago. It is a perfect cube. It's 6. So there's no radical left here. It's just a -6 in the bottom and a 1 in the top. And please remember that we never leave negatives in the denominator. So that's going to be a -1/6. Let's look at number 29, actually 28. I'm going to go back to number 28. Notice that there's a fraction raised to a negative exponent. So the way that we deal with these is we flip the fraction on the inside, and that changes the exponent to a positive. Now what I'm going to try to do here is I'm just going to try to simplify 7/12. I wonder if 7/12 reduces. Alpha y equal 7/112. It reduces to 1/16, which is good. To the 1/4 power, I'm going to rewrite that as the 4th root of 1/16. Now when we take the root of a fraction, you're going to look at it like the 4th root of 1 and the 4th root of 16. The 4th root of 1 is 1, and then the 4th root of 16, let's go to math, number 5. The 4th root of 16 is 2. So this one ends up being nice and pretty. All right, let's jump down to number 29 through 34 are all very similar. What we have to do before we can do anything else is change these back to exponents. So on number 29, we've got v to the 1/3 times v to the 1/2. And remember that when the operation system multiply, we're going to add our exponents. So alpha y equal 1/3 plus 1/2. And that's going to give us 5/6 v to the 5/6, which is the 6th root of v to the 5th. So all of the rest of these are very similar to that right there. You're going to change these back to exponent form. Number 30, we've got r to the 3/4 times r to the 1/2. We add those exponents and we get r 3/4 plus 1/2. And we get 5/4. So it becomes r to the 5/4, which is the 4th root of r to the 5th. Now on this one, r to the 5th, underneath that radical, 5 is bigger than 4. So this is going to reduce. 5 divided by 4 is 1 with a remainder of 1. Put r on the outside and the 4th root of r. The rest of these are going to be very similar after you change them to exponent form. You're going to work them just like we've done the rest of these on the 19 through the 28. So those are your notes on lesson number 2 of chapter 7.